Hello students, in today's video we are going to continue the next part of water hybridization, which is under the topic called as chemical bonding. Now the structure of ammonia and water molecules can also be explained with the help of Sp3 hybridization, right? In ammonia, the central atom is nitrogen and whose atomic number is 7. So therefore we can write the electronic configuration as 1s2, then 2s2 and 2p3. But this 2p3 we can write it as, in the next format I will make you clear, 1s2, 2s2, 2px1, 2py1 and 2pz1, right? So the valence shell is nothing but this part, that is 2s and that of water 2p. Okay, so there are nearly 4 orbitals. Okay, one is of water 2s orbital and the remaining are water 2p orbital. But 2p orbitals, how many are there? 3 are there. And 2s orbital, how many is there? 1 is there, right? So these 2s and 2p will be undergoing hybridization. Okay, so we will get which type of hybrid orbitals? sp3. How many will be there? Totally 4 will be there. Why? Because I have already told you 3 2p orbitals and 1 2s orbitals will be undergoing hybridization, right? And these 4 sp3 hybrid orbitals, if you see the diagram here, right? If you see the diagram here, orbital overlap in a NH3 molecule. Okay, the 4 sp3 hybridized orbital will be directed towards the 4 corners of the tetrahedron. Okay, so therefore I will be writing the central atom N here. So this is one sp3 hybrid orbital, this is another sp3, this is another sp3, and one more will be here towards the 4th corner of the tetrahedron, right? And as I have told you that 2s orbital is undergoing hybridization, so it contains 2 electrons, right? So these 2 electrons will be present in one of the lobe, right? And the remaining 3 sp3 hybrid orbitals will be having 1 electron, right? So these sp3 hybrid orbitals, okay, this is sp3, similarly this is sp3, and this also is sp3. Okay, each of these hybridized orbitals will be overlapping with 1s1 orbital of hydrogen, 1s1 orbital of water hydrogen, to form ammonia molecule, to form water ammonia molecule, right? So let us see this part now. In ammonia, that is NH3, the valence shell outer electronic configuration of nitrogen, in the ground state it is 2s2, 2px1, 2py1 and 2pz1, and having 3 unpaired electrons in sp3 hybrid orbitals, as I have told you. Okay, and a lone pair of electron is present in the 4th one, right? So if you see here, nitrogen in the ground state, that is water 2s2 and water 2p3, but when it undergoes hybridization, how many orbitals? That is 2s orbital and 3 2p orbitals. Totally we will be having water 4, which are those 4 sp3 hybridized orbital, right? In one of the lobe there will be water 2 electrons, and the remaining lobes, which are of water sp3, will be having each 1 electron, and those sp3 hybridized orbital will overlap with 1s1 orbital of hydrogen to form 3 sigma bonds. You can see in the diagram here, right? This is one of the sp3 lobe of nitrogen, another sp3, and this is another sp3. Okay, when it overlaps with hydrogen, we are having here 1 sigma bond, here after overlapping here 1 sigma bond, similarly after overlapping here 1 sigma bond, right? And in the next slide we can see the angle that has been reduced here, right? So therefore we can say that the 3 hybridized orbital overlap with 1s1 orbitals of hydrogen to form 3 nitrogen hydrogen sigma bond, right? And here one concept we have to learn, students, a very important concept it is, let us take into consideration, right? So I will write here lone pair and lone pair will be having more repulsion when compared with lone pair and bond pair, and this will be having more repulsion when considered with that of bond pair and that of bond pair. Okay, so this we have to understand. What is that? Lone pair and lone pair will be having more repulsion when considered with that of lone pair and bond pair, and which will be in turn more repulsive when considered with that of bond pair and bond pair, right? So with this concept we can say that we now know that force of repulsion between the lone pair and bond pair is more. So this is the lone pair and that is the bond pair. Now this we have to find out in the ammonia molecule, right? Actually, when I said you that if there are 4 sp3 hybridized orbitals which are directed towards the 4 corners of the tetrahedron, the bond angle is 109.5 degrees, right? But here what happens? You can see here in this one of this lobe there are 2 electrons here, right? There are 2 electrons. So these are lone pair and these are called as bond pair. So these lone pair and bond pair which are undergoing a repulsion, and for that repulsion this bond angle, what is that? The normal tetrahedral angle 109.5 degrees. If it is undergoing repulsion, then this 109.5 degrees will be reduced to 107 degrees. Okay, thus we can say that the molecule thus gets distorted. Distorted means what? It undergoes change in what? Change in bond angle, and the bond angle will be what? Here 107 degrees. Is it clear, students? And therefore the geometry will be changed. If it was sp3 hybridized without any lone pair, then that the shape of the molecule we would have called it as what? Tetrahedral. But here because of one lone pair there is what? A repulsion. Which type of repulsion? Lone pair and bond pair, and that is the reason now the shape of this molecule is called as what? Pyramidal. Is it clear, student? This concept you have to remember. Now we will consider another example, that is with respect to water molecule, how the water molecule has been formed and what is the bond angle in the case of water molecule, because we should remember that in water molecule there are 2 lone pairs of electron. Okay, let us first try to understand the electronic configuration of oxygen. Oxygen, we know that atomic number is 8, so therefore electronic configuration 1s2, then followed by 2s2 and then followed by 2p4. But this I can elaborate in systematic manner, that is 1s2, 2s2, then followed by 2px, then followed by 2py, and the last one is 2pz. Now these 4 electrons we have to fill in p orbital. Initially 2px1, then followed by 2py1, then followed by 2pz, then comes what? The 4th electron. Now the valence shell is what? 2s and that of what? 2p. So therefore there is a hybridization between s and what? P. Which type of s? 2s. Which type of p? 2p. 2s is how many? Only one 2s orbital. 2p are how many here? 3 are there. That we have to remember. Which are those 3? One is x, other one is y, other one is z. Totally we will get how many? 4 hybridized orbital. Which are those? sp3. 4 sp3 hybridized orbital we are getting. But we have to remember that in the case of hybridization, 2s orbital will be having how many electrons? 2 electrons, and one of the 2px orbital will be having how many electrons? 2 electrons. So therefore out of these 4 sp3 hybridized orbitals which are directed towards 4 corners of a tetrahedron in this manner, if they are directed towards 4 corners of the tetrahedron, the 2 lone pairs. So this is one lone pair and this is what? Another lone pair, and the remaining one of the sp3 hybridized orbital will be having 1 electron, that is with respect to this, and the remaining that is with respect to 2pz. After forming hybridization it will be having what? sp3, and it will be having 1 electron. Now this sp3 hybridized orbital will overlap with 1s1 orbital of hydrogen. Similarly this will overlap with another 1s1 orbital of hydrogen. So there is a formation of sigma bond. So this is a sigma bond and this is what? A sigma bond. Is it clear? But if at all oxygen here, if it is sp3, the bond angle must have been what? 109.5 degrees. But here we can see that here we can see that there are two lone pair of electrons. So this is one lone pair and this is what another lone pair, and these lone pair are undergoing what repulsion, and because of this repulsion the normal tetrahedral angle, rather than being 109.5 degrees, it is reduced to what 104.5 degrees, and thus the molecule's shape becomes distorted means what changed, and that shape either it is called as V shape or it is called as what angular, you can see here, or it is called as angular, or it is even called as what bent shape. Is it clear, students? Now let us try to understand with respect to our explanation here. In the case of H2O molecule, right, 4 oxygen orbitals, which are those? One is what 2s and the remaining 3 are what 2p orbital, undergo which type of hybridization? Sp3 hybridization. After Sp3 hybridization, how many will be formed? 4 will be formed. Which are those 4 Sp3 hybridized orbitals? And out of which 2 will be containing 1 electron, as I have already explained, and the other 2 will be containing a lone pair of electron. You can see the diagram here. 2s orbital, it is here, it is having 2 electrons, and 2px, this is x, this is y and z. After mixing, what will be the hybridization? Sp3 will be the what hybridization. How many will be formed? 4 are there. Why? Because this is 1 and these are what 3. So 3 plus 1 will be what 4, and of these 4, 2 will be having what lone pair of electrons, and the remaining are called as what unpaired electrons, which are involved in bonding. So therefore these are called as bonding electrons, right? So these 4 Sp3 hybrid orbitals acquire tetrahedral geometry. Okay, initially they will be occupying tetrahedral geometry with the two corners occupied by what hydrogen atom. As I have told you in this diagram, you can see here with the 2 corners occupied by what hydrogen atom, while the other 2 by what lone pairs. So this is what the lone pair. You can see here in this diagram here, 2 will be with respect to what the lone pair, and the bond angle in this case is reduced to 104.5 degrees from 109.5 degrees. Okay, and because of the repulsion, we know that which type of repulsion? Lone pair and what lone pair will be much more repulsive when considered with that of lone pair and bond pair, which is much more repulsive when considered with that of bond pair and bond pair. Here which type of interaction we can see? We can see the interaction that is lone pair and bond pair, right? And because of this repulsion, the molecule acquires a V shape or angular geometry, or it is simply called as what bent shape. Is it clear, students? Now let us conclude the so far definitions of what Sp, Sp2 and Sp3 with respect to their examples and all. Okay, now first one is with respect to what Sp. If there are 2 Sp hybrid orbitals, you can see that the bond angle is 180 degrees, right? If the bond angle is 180 degrees, then the molecule is called as what linear, and the best example we have seen, that is beryllium dichloride, right? It is a linear molecule. And the second one, that is with respect to Sp2. If it is Sp2, how many hybrid orbitals will be there? 3 hybrid orbitals will be there. That is 3 Sp2 hybrid orbitals, which are directed towards 3 corners of an equilateral triangle, and all the angles will be 120 degrees. Under such case, the shape of the molecule is called as planar triangular, right? And the best example we have seen, that is boron trichloride. All right. And the next example is with respect to Sp3. Okay, if it is Sp3, then the orbitals will be how many? 4 will be there. 4 Sp3 hybridized orbitals will be there, each of which will be directed towards 4 corners of a tetrahedron, and the angle will be 109.5 degrees, and the shape of the molecule is called as tetrahedral. And the best example for tetrahedral we can see, that is water CH4, which is called as water methane. Okay, similarly I just wanted to concentrate with respect to water. Just now what we have learned, that is ammonia, which is having 1 lone pair, and that of water, which is having water 2 lone pair. No doubt the central atom in ammonia, that is nitrogen, which is having sp3, this also oxygen, that is also water sp3, right? But here, because of the presence of this one lone pair of electron, the angle will be reduced to water 107 degrees. But here you can see that there are two lone pair. This is one lone pair and this is another lone pair, and because of the presence of two lone pair of electrons, repulsion will be more between this, and as a result we can see that the bond angle is reduced to 104.5 degrees. Thus we can conclude that as the number of lone pair of electrons are increasing on the central atom, then the bond angle will be what going on decreasing, right? And now we will understand some other typical example, that is sp3, sp2 and sp hybridization in the next slide. Now let us study with respect to sp3 hybridization in C2H6. Okay, C2H6 is nothing but called as water ethane, right? So ethane, which is represented as CH3 single bond CH3, right? Now let us try to understand the electronic configuration of carbon, whose atomic number is 6. We can write it as 1s2, then followed by 2s2, then followed by 2px1, then followed by 2py1, and the last one will be 2pz0. Okay, this is ground state electronic configuration, and during hybridization the carbon atom accompanies energy, and as a result of which one of the electron which is present in 2s orbital will be occupied in what 2pz orbital. Therefore I can write now as 1s2, then followed by 2s1, then followed by 2px1, then 2py1 and 2pz1. So we can see that there are these hybrid orbitals, these atomic orbitals are available for hybridization. How many will be undergoing? This is 1 and these are what 3. So totally we will be getting 4. Which are those 4? sp3. Okay, and all are having what 1 electron. So therefore after hybridization we can see one of the carbon will be having what 4 sp3 hybridized orbital. Okay, these are the 4 sp3 hybridized orbital. Okay, so initially what happens, we can see that there are here 2 carbon atoms. So therefore there is a need for us to what we can say, there is a need for us to have one more carbon atom. So initially we can say that this was the first carbon atom, and afterwards another carbon atom which will be having the same hybridization. So one will be present in this manner and remaining 3 are what present here. Okay, and the fourth one we can see that will be overlapping with this, right? So therefore there is a formation of what sigma bond. Okay, I forgot to write here, that is what all will be having what 1 electron initially here. Okay, and this also will be having what 1 electron. When the sigma bond is formed, here we can see that one orbital will be donating 1 electron and the remaining sp3 hybridized orbital will be donating 1 more electron. So therefore this is a sigma bond between carbon and carbon. This is a sigma bond between what carbon and carbon, and the remaining sp3 hybridized orbital which are present on each carbon atom will be overlapping with 1s1 orbital of hydrogen to form here sigma bond. Similarly here also it forms a sigma bond. Similarly here also it forms a sigma bond. Okay, and the same thing will be happening with respect to what the other 3 sp3 hybridized orbital of carbon and that of what hydrogen. Okay, so here I can write what the bond pair. So is it clear, students? So this is all happening with respect to what sp3 hybridization in C2H6. Okay, we should remember that in the case of what ethane molecule, okay, there is a carbon sigma bond. Okay, and that is 1. Okay, 1 carbon sigma bond will be there, and how many carbon hydrogen will be there? That is a sigma bond. So you can see that 1, this is 1 2 3 and here 3. So totally will be what 6 carbon hydrogen sigma bond. Is it clear? And if you want to precisely say that in this sigma bond the carbon will be of what sp3 and even this carbon will be what sp3, but whereas in this carbon hydrogen the carbon will be sp3, but hydrogen will be what? S. Is it clear, students? So let us now try to what understand the explanation what we have written here in this water slide, right? So sp3 hybridization in C2H6. In ethane molecule, both the carbon atom assume sp3 hybridization state, right? One of the 4 sp3 hybrid orbitals of carbon atom overlaps what? Axially. So this was nothing but what? Axially. Here what I have shown you, this is what? Axial overlap to form sp3 sigma bond, while the other 3 hybrid orbitals of each carbon atom are used in the formation of sp3s sigma bonds with the hydrogen atom, right? So each carbon hydrogen bond in ethane is sp3s sigma bond with a bond length of 109 picometers. Okay, you can see here this is what? 109 picometers. It means the carbon hydrogen bond length in a saturated system. Saturated means what? A single bonded carbon atom. It is 109 picometer, or it is written as what? 1.09 angstrom. Angstrom in the sense 10 to the power of minus 10. If you shift the decimal, it becomes 10 to the power of minus 12, and 10 to the power of minus 12 is called as picometer, right? And the carbon-carbon bond in sp is sp3 sigma bond with a bond length of 154 picometer, or we can call it as 1.54 angstrom, or we can call it as what? 1.54 angstrom. Is it clear, students? And one can ask me that sir, what are these bonds which are what? This is called as what? A dashed bond. Okay, and this is called as wedge bond. Okay, wedge, not VEG, it is WEDGE. Okay, one has to understand that this is a 3-dimensional structure. Okay, these are this bond is behind the plane of the paper. Okay, but whereas this bond, that is what? The wedge bond, okay, it is projecting out of the plane of the paper towards the observer. Okay, and the remaining this bond are nothing but in the plane. Okay, so I hope you got that. The dashed bond is behind the plane of the paper, and the one which is what? Completely dark, okay, which is projecting towards the observer, and the remaining normal bond are present in the plane of the paper. Now the next example we have to concentrate is on what? Sp2 hybridization. Okay, that is an example with respect to carbon. So the best example is ethene molecule, that is CH2 double bond CH2, right? So let us first write the configuration of carbon. We know atomic number is a 6. We can write it as 1s2, then followed by 2s2, then followed by 2px1, then followed by 2py1, and then followed by 2pz0. This is ground state electronic configuration, and during excitation I have told you what happens. The one of the electron from 2s orbital will be present in what? 2pz orbital. So therefore I can write it as 2s1, 2px1, 2py1 and 2pz1. Okay, but I am speaking with respect to sp2, so therefore there will be only one s orbital and 2 p orbitals are involved in hybridization. So the total number will be what? 3. So therefore we will get 3. Which type of orbitals? sp2 hybridized orbitals. Okay, and this is left behind as it is, that is what? Unhybridized. Okay, during which the 3 sp2 hybridized orbital, if you see here, I will be writing the the systematic representation of sp2. Okay, so one will be present in this manner, right, and one will be present here and the other one will be present here. Okay, and the what we can say that unhybridized, okay, that unhybridized will be present as it is. Okay, so unhybridized 2pz orbital, okay, which will be containing one electron. Okay, and the remaining sp2, so this is sp2 and this is sp2 and this is sp2, each of which will be having one electron, right? But here I have told you we are going to study ethene molecule, but in ethene molecule how many carbon atoms are there? 2 carbon atoms. So therefore another carbon atom of the same hybridization will be present here. So this is one carbon whose one of the sp2 orbital will be overlapping with another sp2 of that of what? A carbon, right? And the remaining will be what present as it is. So the remaining 2 sp2 will be here. So this is one sp2, this is another sp2, each of which will be having one electron, and the unhybridized p orbital we can see that is what present as it is, it will be having one electron, right? So this I have already told you, this is sp2. okay, now this sp2 and sp2 has formed a bond here, which means this is what a sigma bond between what it is, between this carbon and this carbon. So therefore we are having one carbon carbon sigma bond. okay, one carbon carbon sigma bond, but here we should remember it is bond between sp2 bond sp2, right? Is it clear? Now the second part is that we should remember that in ethene molecule there are 4 hydrogen atoms. So one of the hydrogen atom will be overlapping with one sp2 orbital here, right? So therefore this is the second one here, and this is the third one will be here, and this is the fourth one will be here. So altogether we can say that there are 4 carbon hydrogen. Which type of bond? Sigma bond will be there, and if you see in detail it will be sp2 bond s, it will be, okay, it will be what a sp2 bond s. It means that this is sp2 with respect to this carbon, and this is hydrogen is nothing but what a s here, right? And now what happens, we have to see that what about the formation of pi bond. okay, we have to notice that first sigma bond is formed, later only what is formed, a pi bond is formed. okay, the pi bond already we have discussed in our previous video. Pi bond is formed because of what a lateral overlapping. So this will be overlapping above and this will be overlapping here below, but we should remember that overlapping takes place above and below. It is not what a 2 bonds, it is only one pi bond. So I can write this is pi and this is what a pi. Is it clear now? So let us go through this explanation part here. okay, in the formation of ethene molecule, one of the sp2 hybrid orbitals of carbon overlap axially, that is head on overlap with sp2 hybridized orbital of another carbon atom to form a carbon carbon sigma bond that we have learnt here. So this is one carbon carbon sigma bond, right? While the other 2 sp2 hybrid orbitals of each carbon atom are used for making sp2s sigma bond with the 2 hydrogen atoms. So that was present here. So this is hydrogen atom here, and this is another hydrogen atom here with respect to one carbon atom, and the other carbon atom we can see the 2 hydrogen atoms which are overlapping with the sp2 hybridized orbital. okay, and the unhybridized orbital 2px or what 2py. This point we have to remember, students. okay, while explaining also I have told you that 2pz is called as internuclear axis. okay, but in this explanation I have included here as what 2pz, but actually we have to consider that whenever pi bond is formed, it is the bond formed between what 2px or that of what 2py. That you have to remember, right? The unhybridized orbital 2px or 2py of one carbon atom overlaps sideways or laterally with the similar orbital of another carbon atom to form a pi bond, which is always what a weak bond, which consists of 2 equal electron cloud distributed above as well as below the plane of carbon and hydrogen atoms. Is it clear, students? Now let us try to understand with respect to this part here, which is the ethene molecule. okay, so ethene molecule, you can see that this is the carbon atom and this is the carbon atom. okay, and the carbon atoms are sp2 hybridized. If it is sp2, the bond angle is what nearly around 120 degrees, but here they have given precisely as 121.3 degrees, right? And the carbon hydrogen bond length, okay, if it was saturated, in the previous slide we have seen that it was nearly around 109 picometers, but here since the carbon atom is sp2, okay, electronegativity is increased, so therefore bond length becomes what shorter. So the carbon hydrogen bond length in ethene is 108.7 picometers, but whereas that of carbon carbon bond length, you should remember, if it was saturated, that is carbon carbon sigma bond bond, if it was saturated, it was around what, 154 picometer, but here we are now speaking with respect to carbon-carbon double bond, so therefore it is approximately around what, 134 picometer or 1.34 angstrom unit. Is it clear, students? Now the same ethene molecule with effective representation, you can see that, right? So here we can see the carbon atom which is present here on particular thing here, that is what, carbon and carbon here, and this is the sigma bond formed between carbon and carbon, whose bond length is 133 picometers or simply 1.34 angstrom, right? And this is the unhybridized p orbital on each of the carbon atom. It can be either 2px or it can be 2py, but not what, 2pz. Okay, while explaining I have included 2pz for easy going, but one has to remember that what, the unhybridized p orbital while forming pi bond, it is either 2px or 2py, right? So it will be forming above as well as what, below, but only what, one pi bond it will be there, right? And this is the hydrogen which is involved in water bonding with respect to carbon. Again it is what, sigma bond, whose bond length will be approximately around 108.7 angstrom. Okay, and whenever this pi bond gets overlapped, you can see that it is forming water overlap above as well as water below, and the same effective representation which has been mentioned in the below, that is you can see here, that is with respect to what, pi bond overlap above as well as pi bond overlap below. This is the sigma bond which is present between the carbon atom, and the remaining are what, a carbon hydrogen sigma bond which are present within the plane. It means that pi bond is above and below, but whereas the sigma bonds are present within one plane. So the next type of hybridization is sp hybridization, and the best example what we can see is that is acetylene C2H2, or it is simply called as ethane, ETHYNE, right? So again, electronic configuration of carbon we know, that is 1s2, then followed by 2s2, then 2px1, then 2py1 and 2pz0, right? And during excitation, what happens, one of the s electron from 2s orbital will be present in water 2pz orbital. So therefore we are having 2s1, 2px1, 2py1 and 2pz1. Okay, since we are speaking of sp hybridization, we should accompany that only one s orbital, which is that 2s orbital, and the other one is what, 2pz orbital. So these will be undergoing hybridization. So 1 plus 1 it is 2, so we will be getting 2 hybridized orbital, which are those sp hybridized orbital. Since there are 2 sp, okay, so therefore it will be what, 180 degrees. So if you see this, one of the carbon atom will be here, one orbital will be present here, another orbital will be present here, each of which will be having one electron, and the hybridized orbital is simply called as what, sp, and the bond angle is what, 180 degrees. Okay, what about the remaining two? The remaining two are nothing but what, 2px and what, 2py. So the x orbital I can write in this manner, which is having one electron here, and the remaining 2py I can write it here, that will be having again one electron. So this is the picture with respect to one carbon atom. But since I am speaking with respect to ethane, which contains what, 2 carbon atoms, so there is a necessary for us to write one more carbon atom of the same hybridization. So this is one sp hybridized orbital, and this is another sp hybridized orbital. Okay, so here whenever it is forming overlap, we can say that there is a sigma bond formation. This is a sigma bond formation here, and we can see that one electron will be here. And what about the remaining unhybridized orbital, which are those 2px and what, 2py? So this is 2px orbital, and the other one is what, 2py orbital, which will be having one unpaired electron. Okay, now coming back to what, hydrogen. Since there are what, 2 hydrogens in the ethane molecule, so therefore we can say that one of the sp hybridized orbital will overlap with 1s1 orbital of hydrogen to form a sigma bond, and similarly here also it overlaps with the sp orbital of carbon atom to form what, a sigma bond. So therefore if I speak carbon and hydrogen, how many bonds? There will be what? 2 carbon hydrogen bonds in ethane molecule. And if you see which type of bond, predominantly we can say that it is what? Sigma bond, but hybridization of carbon is sp, and that of hydrogen will be what? S, right? And what about with respect to carbon? So there will be one carbon sigma bond, so therefore I will write it as one carbon sigma bond, but the hybridization of carbon will be what? Sp, and this also will be what? Sp. Okay, now we already have understood the structure of ethane molecule in our lower sections. Okay, ethane molecule is nothing but what? HC, then followed by water, triple bond, then followed by hydrogen. So here you can see that in the center this bond is what? Sigma bond. So here above one pi bond and below one pi bond will be there. So therefore in order to have effective overlapping, what happens? One of the px orbital, so this px which is unhybridized, it will be overlapping with the px above, and the same thing will be happening what? Below, right? And the remaining one will be overlapping this 2py and this what? 2py, and the same thing will be happening below here. So therefore we can say that the pi bond which has been formed above as well as below. So this is above pi bond, okay, and this is what? Below pi bond. It doesn't mean that there are 4 pi bonds. Okay, one has to remember that in order to have a pi bond above and below, there will be what? Only one pi bond. Okay, so we have seen that 2 pi bonds are present above as well as what? Below. Now let us have some explanatory part here. Sp hybridization in C2H2, which is nothing but called as ethane molecule, or commonly it is called as acetylene molecule. In the formation of ethane molecule, both the carbon atoms undergo sp hybridization, having 2 unhybridized orbitals, which are those 2py and 2px, right? One of the sp hybrid orbital of one carbon atom overlaps axially, that is head on overlapping with the sp hybrid orbital of other carbon atom. Okay, so that was point here. Okay, that is involving in the formation of what? A sigma bond, right? Atom to form carbon sigma bond, while the other hybridized orbital of each carbon atom overlaps axially with a half filled s orbital of hydrogen, forming what? A sigma bonds. Okay, that was present here. So this is sigma bond with respect to carbon atom and hydrogen, and this is the sigma bond with respect to what? A carbon atom whose hybridization is sp and that of hydrogen is s, right? And if you see the diagrams A, B, C, okay, in case of A we have seen that there is sp of one carbon and other sp of another carbon, which will be having what? Overlap to get what? Sigma bond here, and the remaining part, that is what? Other lobe will be overlapping with hydrogen, right? And what about the 2px and that of what? 2py, that will be involved in the formation of what? A pi bond. Okay, so above is present here pi bond, below is present. Okay, so that is involvement in the formation of pi bond. Thus altogether one can say that acetylene molecule, if you see properly, the pi bond after forming above and below, there is a cylindrical formation of electron cloud. There is what? A cylindrical formation of what? Electron cloud above as well as what? Below. So now to conclude, let us try to analyze what we have studied today, right? So we have studied sp3 hybridization. So the example was what? Ethane molecule, where the bond angle was 109.5 degrees and the shape of the molecule is what? Tetrahedral. And if you see the sigma bond between carbon and carbon, the bond length was 154 picometer, and since it is sp3, the percentage of s in the case of what? Alkane, because this is a saturated hydrocarbon, the percentage of S will be how much? 25%. Since it is a single bonded compound, it is called as saturated compound. S stands for what? Saturated. That is what I have made it for your understanding, right? Similarly, if you take the second example, that is with respect to what? sp2. The example is what? Ethene molecule. Ethene is what? Alkene. These are what? Unsaturated hydrocarbon. US means what? Unsaturated hydrocarbon, and here the bond angle is what? 120 degrees. The shape shape of the molecule is trigonal planar, and if you see here, the bond is what? A double bonded compound. One is a sigma bond, other one is what? A pi bond, and the bond length between carbon of sp2 hybridization is 134 picometer or 1.34 angstrom. Okay, and the percentage of s character in sp2 hybridized orbital will be what? 33.3 percentage, right, or 33%. Okay, and the compound is what? A unsaturated compound. And the last one is that is of water sp hybridization, and the example we have taken is water acetylene, acetylene, or it is simply called as, according to IPAC terminology, as ethane molecule, and the bond angle is 180 degree. Then the shape becomes what? A linear, and the bond length is 110 picometer, which includes what? Here one sigma bond and 2 pi bond. Okay, and the percentage of s will be what? 50% character, and the compound is called as highly unsaturated, and the compound is highly unsaturated, right? So far we have learned hybridization with respect to sp3, sp2 and sp. Okay, in the next class we are going to conclude with respect to hybridization involving d orbitals also. Thank you for watching.